Welcome to Study Loop.
So here we need to determine the best fit for part A, best fit straight line. You can use any graphical software such as Excel or MATLAB in order to find the best fit straight line. Basically, you're trying to find a linear regression for the data. I would recommend using Excel because it's the best. I would say it's the most user-friendly for this type of thing. And so when you plug in the data in Excel, the equation is going to be x equaling 3.03t minus 0.0265 meters. So that would be the units. We know that the initial speed of the ball is the x component of velocity, which from this equation would be 3.03 meters per second squared. So we can say Vx initial would be equal to 3.03 meters per second. This is simply equal to mx plus b. So this b should be a very small number because you shouldn't really start at a negative x position. You should always be starting at an x position of 0. So this should be pretty small in that case. And if you were to graph it, the graph would look like this. So this would be the best fit straight line. And then for part B, we want to find the best fit quadratic equation. And again, I would say using Excel, it's again best user-friendly for this type of problem. And we find that y would be equal to 0.158 minus 0.855t plus 6.09t squared. Again, the units would be in meters. Since the quadratic term in this relationship is 1/2 at squared, we can say that 6.09t squared would be equal to 1/2 at squared. Let's eliminate the t squared, and we find would be approximately 12.18 meters per second squared. So that would be the acceleration for this. And then if you were to graph it using Excel, this is what the graph would look like. Again, an r-squared value of 0.9989, that's extremely good, as close as you can get to 1. That would be 1 is essentially a perfect agreement. It's usually not possible. So 0.9989 is extremely good agreement. So I would say that the more accurate best fit would be a quadratic fit instead of a linear fit. So here, you always want to take into account that r-squared value. The closer it is to 1, the better the model is. And in this case, the better model would, of course, be the quadratic fit. That is the end of the solution. Thank you for watching.